Don't design your network like this. In this video, we're gonna walk through a network we recently worked on, which desperately needed some help. Then we're gonna walk through what we did to fix it by using networking best practices. Let me show you how we did it. So let's start with an overview of the network. So we have three IDFs. We have the warehouse IDF here. We have IDF 505, and we have the MDF/IDF 101. And then within the IDF or the MDF, there's also a server rack. So it's very common for MDF to have an IDF within it. They have usually access switches within the MDF, and it's very common to have your first IDF to be inside the MDF. So here are the switches. Let's walk through these. We have inside the warehouse IDF, we have switch 6. In IDF 505, we have two switches, switch 4 and 5. And then in IDF 101 or the MDF, we have switch 1, 2, and 3. We also have a pair of our core switches, which is part of the distribution layer. And then we have our server rack, which has a switch as well, switch 7. So this is a pretty standard setup, but the problem starts when all of these devices start to connect to one another. So the warehouse IDF is connected to switch 4 within IDF 505. Switch 4 is then connected to switch 5 via Ethernet or copper uplink. And then switch 4 is connected to switch 1 via multi-mode fiber. If you know anything about networking, or if you've seen a network design before, this is a huge red flag already. You can tell this is not proper network design, and you can see why I wanted to show this, and this would be a great example for a network redesign. So let's continue here. So switch 1, 2, and 3 are connected or daisy chained via Ethernet or copper uplinks. And then switch 1 is connected to one of our core switch pairs, and switch 2 is connected to core switch 2, and switch 3 is connected to core switch 2 as well. And then finally, we have switch 7 within the server rack, which is connected to switch 2. A bunch of red flags here, and far, far away from what a proper network design should be. So let's talk about how it's currently set up and how that has an impact on network performance. So daisy chains, first thing, we have to avoid daisy chaining IDFs or switches at all costs. This is bad news, and let me show you why. You can see how switch 6 is connected to switch 4, which is connected to switch 1, right? Because there's no redundancy and we're daisy chaining IDFs or daisy chaining switches. So what happens when the link between switch 1 and switch 4 go down? So when that happens, switch 4 is going to go down, switch 6 is going to go down, and switch 5 is going to go down. All three of the switches are not going to be able to talk back to the core switch. There will be a network outage, basically. So switch 4 and switch 6, that link will not work anymore. Switch 4 to switch 5 will not work anymore. Well, the links will be up, but it doesn't matter because it can't make its way back up to the network, meaning back up to the distribution layer or back up to the core layer, in order to access the internet or access other applications within maybe the server rack. So don't get me wrong, daisy chaining works, but it works when there aren't any issues, right? But things happen and things break, and someone working in the rack maybe accidentally knocks over the power cable for switch 1, or someone is doing maintenance and they cut the cable between switch 1 and switch 4, right? This happens, and it could be on accident, a switch fails, or whatever it is. We're gonna have a high chance of failure and a network outage by having a network design like this. Also, when an MDF has multiple switches, it gets very confusing from a network management perspective to have different IP addresses per IDF. So because these switches are not stacked, each switch has its own IP address, right? So switch 1 has an IP address, switch 2 has an IP address, and so on. This is not common, and you don't want to do this because it just gets really confusing from a network management perspective. So let's talk about how this network should look after a redesign so that we're not daisy chaining IDFs and that we're stacking our switches properly. So this is a high overview of how we would want to design this network. But let's start from the beginning here. So we're going to first stack our switches. Switch 1, switch 2, and switch 3 is going to be stacked. And I'll show you an example of what stacking looks like. This is just a photo I found online. And these are stack cables behind switches. And what it does, it creates multiple physical switches into one virtual switch. So it's easy to network manage. If you're a network technician, a network engineer, or a network admin, got to be familiar with network stacking or switch stacking. So the first thing we're doing is stacking these switches, right, that have IDFs that have multiple switches in them. So switch 1, 2, and 3 will be stacked. Switch 4 and 5 will be stacked in IDF 505. And in the warehouse IDF, since we don't have another switch in there, it's just a single switch, there's no need to stack it, right? The core switches are stacked as well. First thing, stack your switches. Make sure network management is working properly. Let's start with the first connection here. So we're going to start with the warehouse IDF, switch 6. We're going to have a fiber link. Usually it's fiber for our uplinks for bandwidth purposes and speed purposes. So we're going to have a link from switch 6 to the core switch 1. And then we're going to have another link to core switch 2 from the warehouse IDF. Very standard. This is exactly what you want to do. Add redundancy. So if this link goes down, right, we still have connectivity up to the core layer, up to the distribution layer. And if this link goes down, this link is still up, right? So it just provides that level of redundancy, which we didn't have in the previous model. So let's move on to IDF 505. Switch 4 is going to be connected to core switch 1, and switch 5 is going to connect to core switch 2. You can see the redundancy here, and because they're acting as one virtual switch with the stack cable, if this link goes down and switch 4 and switch 5 will still have connectivity up to the core layer. Say the SFP goes bad, or there's a fiber cut, or the SFP on this side goes bad, right? We'll still have connectivity up to the core layer. And then let's start with switch 1, 2, and 3. So we're going to have switch 1 connect up to core switch 1. And then we're going to have switch 2 connect up to core switch 2. Provides, again, the same thing as IDF 505, redundancy between this stack of switches and the core layer. And the server rack, lastly, is switch 7, very similar to the warehouse IDF. We're going to have 2 links in between switch 7 and the core layer or the distribution layer. And again, just provides redundancy so that if one of these links go down, we still have connectivity up to switch from switch 7 to the core layer. And then let's talk about network management. And this is what I was mentioning earlier, how one switch or an IDF, right, has one management IP, right? Switch 1, 2, and 3, they have one IP. Switch 7 has one IP. Warehouse IDF has one IP. The reason why you're not doing this is because maybe there's another network that lives in your facility within your IDF. So like the security cameras, for instance, sometimes are on their own network, which is managed by some security vendor. So that's why you wouldn't stack those switches with your internal network. So you can really see the difference in network design by looking at how the network was set up before compared to how a redesign would look like. It's important to follow network design best practices because there was a lot of hands that touch a network over the years. People change jobs, and the people that remember that the warehouse IDF is daisy chained off IDF 505, which is daisy chained off switch 1, will not be around to help. During troubleshooting for someone unfamiliar with the network setup, this can be a huge nightmare. And as a low voltage contractor, this is not required for us to know this type of information, but with a background in network engineering, it's important to provide our clients with the most amount of value as possible. Instead of just running cables from point A to point B, we can actually provide reasoning and justification for each connection that we make when consulting with our clients. And for IT staff that has limited experience or are working remotely that manage a bunch of different sites, having a low voltage partner that understands networking, we have found to be a big help. Anyways, I want to thank you guys for watching, and I hope to see you guys on the next one.